Hey, welcome to Draft Academy. My name's Mike. This video is part of a series of videos where I'll be going over the basic syntax of different programming languages. Now, one of the most annoying things about picking up a new programming language is having to learn all the syntax from scratch. In my own experience, it generally manifests in a lot of Google searching and Stack Overflow. For an experienced developer, the problem isn't understanding the concepts of programming, it's knowing how to implement those concepts in the new language. So things like variables, data types, data structures, loops, conditionals, and object orientation. All of these things are done a little bit differently in each programming language, and having to research how to do it all can be extremely annoying and tedious. In this video, I'll go through and show you the basic syntax for the most common parts of the language. I'll give you a brief history of the language, and we'll touch on some of the best practices and conventions used in that language. Now, this is meant to be a quick run-through. I won't be showing you how to install or configure anything, and we won't really have time to learn how to do everything. You see, I've distilled it down into what I consider the core concepts, so the goal for this is to be a quick video, so I can't cover every aspect of the language. With that being said, this video is meant for programmers who already understand the core concepts of programming. It's not going to teach you any programming concepts. I'll simply show you how to do all the common things in the new language. So if you are new to programming, Draft Academy has hundreds of videos where I hold your hand and I walk you through everything you need to learn to program, but this is meant for developers who already understand programming. So without further ado, let's get started. Python is a general-purpose, dynamically typed and interpreted, object-oriented programming language that was created in the late 1980s by Guido van Rossum. Python's design philosophy revolves around readability. It's meant to be easy to read and easy to write. This is accomplished using white space to delineate code blocks instead of the more traditional curly brackets and semicolons. Generally, all Python code is run using an interpreter. The most popular and original interpreter is called CPython because it's implemented in the C programming language. Several other interpreters exist, however, many of which are implemented in languages other than C, like Java and C#. The most common Python interpreter, CPython, uses an automatic garbage collector to manage memory, and Python is widely known for having a non-traditional minimalist syntax, which is largely based on white space indentation and designed to be clean and readable. When first getting into Python, it can be a bit confusing because unlike a lot of other programming languages, Python actually has two major non-compatible versions that are currently widely used by developers. There's Python 2, the latest version of which is Python 2.7.3, and then you have Python 3. Now, Python 2 is the legacy language. It's the old version of the language, and actually the founder, Guido van Rossum, decided that after Python 2, he wanted to kind of overhaul some of the different features in the Python programming language, thus creating Python 3. Now, Python 3 was initially adopted fairly slowly just because the Python 2 ecosystem was so well built. And one of the problems was that Python 3 was not backwards compatible with Python 2. So all of those modules and all that code that had been written for Python 2 could no longer work in Python 3. But nowadays, the Python 3 ecosystem has for the most part caught up, making it the most obvious choice for new developers looking to get into the language. And obviously, 5-10 years from now, Python 3 is going to be the dominant version. Python 3 is also the version of the language that we'll be looking at in this tutorial. So many developers choose to write Python in a simple text editor, but there are also more specialized integrated development environments. Some of those popular include Eclipse, PyCharm, and Vim. All right, so let's get started. Over here, I have a Python file, and you notice it's blank. And one of the cool things about Python is you don't need anything set up. You don't need any classes or functions. You can just kind of write code right here in this file, and it'll start working. And the extension is .py. So I have this file app.py for app.python. And then over here, I have my command line, my terminal, which is where I'm going to be executing all of the code. First thing we're going to look at is printing. And I also want to talk to you guys about how Python code is formatted. So Python doesn't use semicolons and it doesn't use curly brackets to delineate code blocks. Python's all about white space. So in Python, you use white space to delineate code blocks. So you'll see down here, I have these 3 print statements, and this is just how I could print something out onto the screen. But you'll notice over here that this print statement has an extra white space in front of it. Now, because white space is used to delineate code blocks in Python, you actually have to be careful where you put the white space. So for example, in a program like this is actually going to throw an error because I have an unexpected indent right here. So if I was to run this program, you'll see that I get this error. It says unexpected indent. indentation error. So you always want to make sure in Python that all the code that's supposed to be on the same block is at the same indentation level. And indentations can be created using tabs or spaces. However, it's recommended that you use spaces instead of tabs. Now, spaces and tabs in Python aren't going to work well together. So if you indent something with a tab and then you indent something with a space, Python's not going to be able to handle that. And according to the Python style guides, you want to make sure that you use spaces, and you always want to indent using 4 spaces. That's kind of like the standard. However, you can indent using any number of spaces that you want. So now that we kind of understand indents, let me show you guys how we can print. So I can just print like this, basically just, saying print and then printing whatever you want there as a string. We can also use variables in Python. So in Python, we can use variables to store and keep track of different pieces of information. You'll see over here, I have a single line comment, which is just using this hash. And then I have the multi-line comment, which is just using 3 of these single quotes. So Python variable names are case sensitive, and they can begin with letters, a $, or an underscore. And after that, they can include letters, numbers, $, or an underscore. Convention says to start with a lowercase word, and then additional words are separated with an underscore. So you'll see over here, I have my first variable. All the words are separated using an underscore. And then down here, I just have an explanation of a couple different data types. Python is a dynamically typed language, so you don't have to worry too much about what different types are being used, but there are a few different types that we can talk about. So over here, we have a string, which is just using these quotation marks. This is just going to be like plain text. Then we have an integer, which is like a whole number. We have a decimal number. Sometimes you'll hear people call these doubles or floats. And then we have a Boolean. So over here, the Boolean can have one of 2 values, either true, and that's with a capital T, or false with a capital F. If you want, you can modify the variable. So you'll see over here, I'm modifying this string. I'm just saying name is equal to John. And then down here, we can print out variables a couple different ways. So I'm showing you guys a few down here. You can just put them in the print statement, and you can either use concatenation, or you can use a special way that we can do this in Python. So concatenation, I just have the string, and then I'm concatenating on the value inside the variable, or you can just put the string here, put a comma, and then the name of the variable, and Python will automatically insert this here after the string. So those are 2 different ways you can do it, and it's really just personal preference which one you want to use. And you can see over here, we're printing out the 2 variables. Now let's talk about casting and converting. So I can actually convert one data type into another data type, and because Python's dynamic, it does this really well. You can see over here, if I wanted to cast, I can just say the name of the data type, like int, and then inside of these parentheses, I can put like a double, and you'll see over here, it converts it into a double. I can do the same thing for float. So this would be like, I can convert an integer into a floating point number, so we get 3.0. I could also convert like a Boolean value, like true, into a string, and you can see we just print out true. Or I could actually convert a string into a number. So down here I have int, and in here I put a string with the number 50 in it, and I also put a string with the number 70 in it. And you'll see I can actually add both of these together. So 70 plus 50 is going to be 120. And that can be really useful, obviously, getting numbers out of strings. Let's take a look at strings now. So strings, one of the most common data types that you're using in Python. And over here, I'm just creating a string variable called greeting. Strings are going to have specific index positions. So strings are indexed starting with 0, and this is pretty standard in other programming languages as well. But you can see, even though H is the first character in the greeting string, it's technically at index position 0. So you can use those index positions to reference specific characters inside of the string. If I wanted to get the length of a string, I can just use this length function. So it's just len, and then inside of parentheses, I can just pass in the string, and this will tell me 5. So it's telling me that it has 5 characters. If you want, you can access specific characters using their index position. So the way we do that is just by referring to the variable name or just the string itself, and then an open and close square bracket, and then inside here you can pass a index position. So greeting 0 is going to give us an H. In addition to putting a positive number, you could also put a negative number in here. So I could say greeting -1, and this is going to grab characters from the end of the string. So now I'm going to get this 0 because we can count backwards. So this would be -1, -2, -3, etc. So you see over here we get O because that's -1. You can also check to see if a string contains another string. So like greeting.find will tell me if this string is inside of this string, and if it is, it'll tell me at what index position it starts. So over here you'll see it says 2 because LLO starts at index position 2. You can see 2, 3, 4. And if you put a string over here that isn't inside of the string, so if I put a Z here, Z isn't inside hello, so it's going to give me a -1 back. You can also use a substring, so I could grab just like a part of a string, and Python actually has a really cool way to do that. We can do it from inside of these square brackets. So I could say like 2 and then a colon, and what this is going to do is it's going to grab the string starting at index position 2 and going to the end. So we'll start at 2 and we'll grab LLO. You'll see over here it's printing out LLO. Or you can specify an ending index. So I could say start at 2 and end at 3. So it's just going to grab 2 and it's going to end at 3, and it's not actually going to grab that third character. So that's why we get L over here. So those are different ways that you can grab like specific parts of a string. Now I want to talk to you guys about numbers. So there's all sorts of stuff that we can do with numbers, and over here I'm just showing you guys some basic stuff. So I can do like 2 times 3, can do basic arithmetic, and that'll print out 6 because that's the answer. So you can do addition, subtraction, division, and multiplication. You can also do power. So I could say 2 asterisk asterisk 3, and this is going to give me 2 taken to the third power. So you'll see over here we get 8. And then we can do the modulus operator. So I could do like 10 mod 3, and that's going to give me the remainder of division. So it's going to say 10 divided by 3 is 3 with a remainder of 1. And it's going to give me that remainder. So you'll see we get a 1 over here. You can also specify order of operations. So if I have like a math equation over here, 1 plus 2 times 3, this is going to do the multiplication first and then the division. So it's going to say 3 times 2 is 6 plus 1 is 7. But if I wanted to do the addition first, I could just put parentheses around here, and now it's going to do this first. So it'll be 1 plus 2 is 3 times 3. And if I run the program again, you'll see that we get 9 instead. And then I also want to show you guys how integers and doubles, or integers and floating point numbers, interact with each other. So here I have an integer divided by a floating point number, and you'll see we get a floating point number back. So we get 3.3 repeated. But if I was to change this into a integer, so now I have an integer and an integer, you'll see that we still get a floating point number back. And this is actually different from a lot of other programming languages. In a lot of other programming languages, when you do math on 2 integers, you usually get an integer back, but Python is different. So that's something to keep in mind. We can also come down here and do some other stuff. So you'll see I have this variable here, num, and I'm setting it equal to 10. I can say num plus equals 100. And what this is going to do is it's actually going to take the num and add 100 to it and then store that back in the num variable. So you'll see here we get 110 because num is now equal to 10 plus 100. You can do plus equals, minus equals, divide equals, and multiplication equals. And then down here, finally, we have just some math stuff that we can do. So if you're going to use the math stuff, then you want to go ahead and import math, and that's just going to import the Python math library for you. And you'll see over here, some of them you need the math library and some of them you don't. So for example, POW is just, I can say POW23, and that'll give me 2 raised to the third power, which is 8. I can say math.sqrt, math.square root, and this will give me the square root of 144, which is going to be 12. I could also say round 2.7, and that'll round 2.7 up to 3. So some of these, you don't need this math module, but some of them you do. And if you want to find more of these math functions, you can just look up that math module online for the API. Now let's talk about getting input from the user. So obviously in any programming language, there's tons of ways that you can get input. I'm just going to show you guys how to get input from the console over here. So it's actually really easy. Python makes this super simple. What I'm doing here is I'm basically defining a variable called name, and I'm setting it equal to input. And then inside these parentheses, we have a prompt. So input and then the prompt in here is going to prompt the user. And then it's going to pause the execution of the program, wait for the user to enter something. Whatever the user enters, it's going to store inside of this name variable, and then we can print it out down here. So if I put my name like Mike over here, you'll see it says hello Mike, so it's saying hi to me. So basically in one line you can prompt the user, get the input from them, and store it in a variable. You'll see down here I'm actually getting integers. So over here I'm using the same input, enter first num, input, enter second num, but I'm converting it into an integer. So by default, when you use input, it's gonna take whatever gets input and store it as a string. So if you want it to be stored as a number like an int, then all you have to do is just do what I showed you guys before and convert it into an integer, and then we can add them together. So I can say like enter first num 10, enter second num 20, and you'll see over here we get 30 as an answer. All right, now I want to talk to you guys about lists in Python. So lists are actually very similar to arrays. in other languages. They're not exactly the same, but they're very similar. It's doing the same thing, allowing you to store multiple pieces of information in the same structure. So if you're familiar with arrays, then you're going to be just fine with lists. And over here, I'm creating a list called lucky nums, and I'm setting it equal to all of this information. So here inside of these square brackets, I can just put a bunch of different elements. And what's cool about Python, because it's dynamic, is I can actually store whatever data types I want inside of this list. So I could have integers, I could have a string, and I could have more numbers and even something like a double here, all in the same structure, all in the same list. So down here, I can access individual elements in the array by referring to the array's name, and then inside of square brackets, referring to the index position. And array indexes are just like string indexes, so we start at 0, so the first element in the array is an index position 0. And then down here, you'll see I'm just like printing out a bunch of stuff. So I'm printing out lucky number 0, which is 90, lucky numbers 1, which is 8. And just like with strings, you can use negative numbers in here to grab elements from the back of the list. So lucky numbers -1 is going to be this 42, as you can see. You can also, just like with strings, you can get like substrings or like subsections of the list. So I could say like 2 colon, and this will grab everything starting at the second position. So 15 all the way up to 42. Or you can specify that ending index. So now we'll grab 2 to 4. So 15 and 16, just like that. And then you can also get the length of an array just by using this length function, len, and then inside of here passing in the structure, which is going to be 6. So that's basically how we can use lists to do a bunch of different stuff. You can also define n-dimensional lists, so 2, 3, 4, 5 dimensional lists, like whatever you want. And I'm kind of showing you guys up here how to do that. So I'm saying number grid is equal to, and then inside of these square brackets, I have 2 additional arrays just like that, and I can access them just like that. So 0, 1 is going to be this element, and then this element inside of there. So I'm setting that equal to 99. See, I'm printing out 0, 0, which is this 1, and then 0, 1, which is that 99. And this basic concept will apply to, like I said, n-dimensional lists. So 3, 4, 5 dimensions, whatever your heart desires. All right, now let's look at some other stuff we can do with lists. So obviously we looked at like how to create a list, how to access elements in a list, but there's actually a lot of different functions that we can use on these lists. So over here, I just have an empty list, friends is equal to empty list. I can use this append method, which is just going to append elements onto the end of the list. So I could say like friends.append Oscar, Angela, and I can also insert an element into a specific position. So I can put the position I want to insert it into, and then the element that I want to insert. And over here, I can just print out the array by just saying print friends. So over here, I'm printing out the friends array. So we have Oscar, and then we inserted Kevin at index position 1, and then Angela is going to be there at the end. I can also figure out whether or not a specific element is inside of the list, and if it is, I can get the index. So I can say friends.index Oscar, for example, and this will tell me at what index position Oscar is in the array. So I can say index Oscar, and you'll see it's 0 because Oscar is at the 0th position in the array. It's right there. I can also say count, and count will tell me how many times a specific element shows up in the list. So I can say friends count Angela. This is going to give me a 1 back because Angela shows up 1 time in the list. You can also sort a list, so I could say friends.sort, and you'll see now it's sorting it alphabetically. And because all of these guys are strings, Python's able to, figure out the best way for us to sort it. And then you can clear an array by saying friends.clear, and then you'll see down here we just get this empty array. If you want, you can also remove elements. So I could say friends.remove and then the specific element that I want to remove. Now if I ran this file again, you'll see that Kevin doesn't show up in the list because I removed him. So there's a lot of these different array functions. I mean, everything that you'd expect to be able to do with a dynamic array, you can do pretty much with a Python list. Another structure that we can represent in Python is called a tuple or a tuple. And this is basically just an immutable array. So it's exactly the same thing as an array, except it's immutable. So once you define the tuple, you can't change it. So over here, I have a tuple of lucky numbers, and you can see I'm just giving it all these same values that we gave to that array. And the index positions are exactly the same thing. The only difference here is that we can't modify this. So you can see I can do all the same stuff down here that I did with the list, but I couldn't modify it. So if I came over here and tried to say like lucky number 0 is equal to 90, it's not going to let me do this. So if I ran my program now, you'll see we're getting this error because you can't modify a value that's inside of a tuple. And there are, certain circumstances where these will come in handy. I think by far arrays or lists in this case are a lot more common, but tuples do serve some purposes. So now I want to talk to you guys about functions. So we can define functions in Python, and basically these are little blocks of code that we can reuse and that we can call throughout our program. The way you define a function is just by saying def and then the function name. And functions are generally named the same as variables. And then inside of parentheses, we can define some parameters. So because Python's a dynamic language, you don't have to specify the data type that this is going to take in. I can just say the name of the variable, the name of the parameter that I want to accept. And what you can do is you can actually give these default values. So I could say like num1 and I could say num2, and I could give this parameter a default value. So if the user didn't enter in a value for parameter 2, then it would automatically just get set to 99. And then down here, this return keyword will break us out of the function. And I'm basically just using this function to add these two numbers together. So down here, I'm creating a variable called sum, and I'm setting it equal to the result of adding 4 and 3. And also, before I forget, you also need this colon over here. So this is like the whole way that you would define a function. And again, the function is going to be delineated with white space. So anything that's indented from this top line is going to be considered inside of the function. But when I write code over here that's at the same indentation as the function declaration, that's going to be considered outside of the function. So, using this white space can take a little bit getting used to if you're coming from a more traditional curly brackets language, but you'll find that it's actually pretty easy to use and pretty readable. So over here, I'm assigning the result of adding these into the sum variable and printing it out. And as you can see, we get 7 because 4 plus 3 is equal to 7. If I was to get rid of this 3 though, you'll notice that up here, we're giving this a default value. So now when I run my program, we're going to get 103 because num2 is automatically just going to be set to 99. All right, now let's talk a little bit about if statements. So if statements are conditionals. It allows us to respond to the information that's inside of our programs. So I have two Booleans here. They're both equal to false. One's called isStudent, one's called isSmart. So down here, I can define the if statement. So I can just say if isStudent and isSmart. So you can use and, you can also use or, and those are both going to account for and or logic. I can also use else if. So in Python, it's just elif, and then I can check another condition. And you can also use a negation operator. So I could just say not, and then inside of these parentheses, I could put whatever the condition is, and this will negate the condition. So not is smart is going to give us the opposite of the is smart Boolean. And then finally, we can just say else. And you'll notice each of these is using that colon just like we used for the function. And again, you want to pay attention to the indentation levels of all of this code. You can use straight up Booleans. You can also use comparisons. So you can use comparisons to get Booleans for you. So I could say like if 1 is greater than 3. And so in this case, this is going to be false. I could also say though like 1 is less than 3, and now this is going to be true. And it says number comparison was true. So you can use greater than, less than, greater than or equal to, less than or equal to, not equal to, or double equals. All of those are going to allow you to compare different values. You can also compare strings. So I could say like if dog is equal to cat, and that'll basically allow me to compare two different strings. Next, I want to talk to you guys about dictionaries. This is another kind of like data structure. Basically, this will allow us to store key value pairs inside of a structure. So it's essentially a list, but instead of just storing elements, we can store key value pairs. So over here, I have this test grades dictionary, and it's just like a list, like I said, but instead of using square brackets, we're going to use these curly brackets. And then inside of here, we can define keys and values. So this is the key, and this is the value. And all the keys need to be unique, but the values can be repeated if you want. So over here, I have like the Andy key corresponds to the B plus value. This is just like maybe the grades that students got on a test. So the keys can be strings. The keys could also be numbers. So like 3 would be a valid key. And then we can, store strings, any types of numbers or even Booleans inside of here. And then we want to access this. I can just say test grades, and then in square brackets, I can insert the key that I want to access. So when I say test grades Andy, this is going to give me B plus because that's the grade that Andy got on the test. In addition to using these square brackets, you can also use this get function. So I could say testgrades.get. And what's cool about the get function is we can define a backup value. So I could say testgrades.get Ryan. And this is going to try to get this Ryan attribute over here. So In our case, Ryan is inside the dictionary, so we're going to return A. But if I was to change this to like Doug, for example, and then I ran this program again, you'll notice that instead of saying something, it says no student found. So it's defaulting to whatever we passed in here as the second argument, and that can be pretty useful. And then finally, we could access this by just saying test grades 3. So this could actually get a little bit confusing. This isn't going to grab the entry at index position 3. This is going to grab the entry that has the key of 3. So just make sure that you understand that distinction. And dictionaries can be pretty great just to represent like little objects of information. Next, we're going to talk about loops. So the most basic type of loop in Python is a while loop, and it's a very simple loop that's just going to keep looping over a block of code while a certain condition is true. So over here, I have this variable index. It's given a value of 1, and I'm saying while index is less than or equal to 5, and again, we have this colon here, I'm going to print out the value of index, and then I'm going to increment index by 1. So you see over here, we're printing out values 1 through 5. So we're going to keep printing as long as this condition is true. One thing you want to watch out for are infinite loops. So if I was to like get rid of this line of code, now we have a recipe for an infinite loop because this condition up here is always going to be true because we're never incrementing index. So just want to make sure that you watch out for that. Next, we can take a look at for loops, and for loops are more specific loops. They're used for iterating over structures or iterating over different things. So the most basic is we could iterate over a range. So I could say like for index in range, and now this index variable is going to represent the values 0 through 4 as we go through the loop. So you'll see at the first iteration, we start at 0, then 1, 2, 3, and 4. So we're printing out 5 times, but we're starting at 0. And that's usually how you would do this in a normal programming language. So you can do that. You can range through a specific amount of times. You could also range through a structure like a list. So over here, I have this lucky nums list. I could say for lucky num in lucky nums. And then down here, I'll just print out lucky num. And this is going to go ahead and print out all the elements in the array. So we get 4, 8, 15, 16, 23, 42, etc. That's a really useful way to loop through different structures. You could also loop through like a string, for example. So I could say for letter in giraffe. And then down here, I could just print out letter. And so now I'm printing out all the letters inside of this string. So Python for loops are very flexible. You can basically just use them to loop over any collection. So, in this case, we could loop over like a string or an array or a range of numbers. Now I want to talk to you guys about exception catching. So a lot of times in your Python programs, something will go wrong and Python's not going to be able to handle it. And so what you want to do is implement some sort of exception catching. So over here, I have a situation. This is a line of code that'll throw an exception. So I'm saying the variable answer is equal to 10 divided by, and then right here, this little line is just getting a number from the user. So I'm saying input, enter number, I'm converting it into an integer. So if I was to enter in like a 0 here, for example, it says enter number. If I put a 0 in here, you'll notice that I'm trying to divide by 0. So basically what I'm trying to do is 10 divided by 0. And you'll see we get this 0 division error down here. So that was a problem. Another thing that might go wrong is I might put a non-number. So if I put like a letter in here, now it's going to try to divide 10 by a number. So it's over here, it's trying to convert whatever they entered into an integer. It's not going to be able to do that. And you'll see that we get another error. So we get a value error. So this is a situation where we 2 potential exceptions could get thrown. So let's talk about how we could handle that. I could put this line of code inside of a try block. So over here, I'll put this code in a try block. And now when I run this program and I say like, if I entered in a 0, now, instead of the program crashing, it's just going to handle it. It'll come down here, execute this code. It'll print out error. You can also catch specific errors. So I could come down here and I have this block of code. It's doing the same thing, but now instead of just having except right there, we can just say except 0 division error as E. And so what I'm doing now is I'm catching this specific error and I'm storing it inside of this E variable, and then I can print it out. So now if I have a 0 division error, you'll see it just says division by 0 because that's what it's printing out with E down here. And you could have multiple. So I could also catch that value error if I wanted to. And then you could also just have a general except down here, and this will just catch any exception. So if I did that value error exception, I put like an A here, it just says caught any exception. Now this is generally considered to be kind of a big no-no, just because when you're putting a general except statement there, it's just so broad in general that it'll catch everything. And a lot of times in your programs, like you're not going to want to catch specific errors or specific exceptions that happen. So if you're going to do something like this, use it wisely. Generally, you want to catch a specific error like that zero division error and then be able to handle it accordingly. Now we're going to get into object orientation. So Python is a fully object-oriented programming language, so you can do basically all the stuff that you can do in a normal object-oriented programming language in Python. So over here I have a class, and it's a book class. Inside of this book class I have a constructor. So this is actually a constructor. This is a method that's going to get called when we create an instance of the book class, and it's just 2 underscores in it and then 2 other underscores. And then over here you always want to put self. Now self is a keyword that you're going to see a lot in Python, and self is going to refer to the specific instance of the class. So self will refer to the object that's getting created, and you always just want to pass that in anytime you have a function inside of your class. So you'll see over here I have this read book function. I'm also passing in self. And then over here in the constructor, I'm taking in 2 arguments, title and then author. And then down here I can say self.title is equal to title, self.author is equal to author. So this is how I can define and populate some attributes of my class. And like I said, I have a function down here. So this is a class function, and I'm passing in self, and then I'm just saying reading self.title by self.author. So this is going to say reading whatever the title of the book is by whatever the author is for that specific object. Down here I can create an object. So I'm creating a variable here called book1, and I'm storing an object inside of it. So I'm storing a book object. And whenever I say book like this, that's calling this constructor up here. So I need to pass in the title, and I need to pass in the author, and self is going to get automatically passed in. And again, that's just going to be the specific instance of the class. So down here I can print out like book1.title, so I'm printing out Harry Potter, and then I can print out book1.readbook, which is just going to be reading Harry Potter by J.K. Rowling. You can also modify this, so I could say like book1.title is equal to Half-Blood Prince. Now when I run the program, the title gets updated. So again, a couple of things to take away from here. You always need to use this self keyword, and that'll refer to the specific object that got created or that's trying to access, for example, the constructor or this function. All right, next thing I want to talk to you guys about are getters and setters. So getters and setters is basically a design pattern that you can use in object-oriented programming, which allows you to control the access that outside code has to the attributes of your class. A lot of times in Python, people won't use getters and setters. So it's not uncommon in Python to see a class that doesn't use getters and setters. And honestly, it's probably more common to not use them than to use them in the first place. But if you're using object orientation and you're writing classes and you're using objects and stuff like that, getters and setters do serve a very valid and important purpose. So if you want to use them, I'll show you guys how to do it. So here I have my book class. Down here I have that same constructor, and what we can do is we can actually define a property. So I can just say at property, and I'm just saying def title self. And basically what I'm doing is I'm creating a function for the specific attribute. So I'm creating this like title function, and this is actually going to be the getter. So you'll see over here it says print getting title, and I just put that in there so it's obvious, and then we're returning self dot underscore title. And when we use these properties, we're using underscore title as the name of the actual attribute, and this underscore basically signifies that this attribute is going to be private. And then over here we have our setter. So I just said at title.setter, and it's just def title, and over here we're passing in a value. So I'm setting the title, and again I'm just saying self.underscore title value, and then we have our deleter right there. So now anytime that I try to use that title, it's going to automatically go through these functions. So anytime I try to set it, either it's up here in the constructor or if it's down here in external code, it's automatically going to go through these functions. It's not going to set the attribute directly. So down here, I'm using the constructor. You'll see I'm creating a book, and here it says setting title, and that's when it's calling that constructor. And then down here, I'm printing out book1.title, and you'll see over here it says getting title, and then it prints out the title. And I'm saying book1.readbook, and then down here you'll see it saying self.title, and that's also getting the title. So anytime that you access that attribute now, you're going through the getter or the setter. All right, now I want to talk to you guys about one final topic in Python object orientation, which is inheritance. And inheritance is basically where a class can inherit all the attributes and functionality of a other class. So we would say we have a superclass, and then we have subclasses which are inheriting the attributes, the functions from that superclass. So over here I have a class called chef, and it just has a few methods in here, def make chicken. So this is the make chicken function, make salad, and make special dish. So the chef can do 3 things. And then down here, I have another class called Italian Chef. And you notice in parentheses, I put chef. And basically, this tells Python that the Italian Chef is going to inherit all the functionality from the chef class. So in the Italian Chef class, I just have two methods. I have this make pasta method, and then I have this make special dish method. And you'll notice that this make special dish method is also inside of the chef class, so I'm actually overriding it down here. So down here, I'm creating a chef object. So I'm saying my chef is equal to chef, my chef.make chicken, and then I'm creating an Italian chef object. My Italian chef is equal to Italian chef, my Italian chef.make chicken. So even though make chicken isn't defined inside of the Italian chef class, I can still use it because I'm inheriting that functionality from the chef superclass. And then if I wanted, since I overrode this make special dish method, I could come down here and I could say like make special dish. So now the chef is actually gonna make a different special dish than the Italian chef. So over here, you'll notice the chef makes barbecue ribs, and then the Italian chef makes chicken parm. So that's kind of how we can work with inheritance, how we can override functionality that we've inherited in a subclass. And inheritance can be extremely useful in Python. All right, so I want to show you guys one more thing with basic Python inheritance, which is using that init function or using a constructor in a subclass. So over here, I have my superclass, which is chef, and you'll notice that I added in this init function. Basically, the constructor, it gets called when we create an instance of this class. And down here, I'm saying that the chef class is going to have two attributes, a name and an age, and those are just getting passed in as parameters. But let's say that down here in the Italian chef class, which is the subclass, I also want to have a constructor. So you'll notice down here, I added in another attribute. So the Italian chef also has a country of origin associated to it. So down here, I'm setting the country of origin, which gets passed into the constructor. And then over here, what I'm doing is I'm actually calling the superclasses constructor. So I'm just saying super and then dot init, and then over here I'm passing in the name and the age. So this is basically me initializing the name and the age that we inherited from the superclass. And then this is basically how we can do something like that in Python. So then down here in the code, you'll notice that I created a chef and I passed it a name and an age, Gordon Ramsay and 50. And then down here, I created an Italian chef and I passed it a name and age, and then also this country of origin, which is Italy. So down here, I can print out like my Italian chef.age, and we get 50. So that's basically how we could do something like that. Essentially, this is a case where in the subclass, I'm basically overriding the constructor. I'm overriding that init function. But then if I still want to use the constructor that's in the superclass, I can just say, like I said over here, super.init, and then pass it whatever it needs to get. All right, so there's one more thing I want to show you guys with Python, and it's actually called the Python interpreter. And the Python interpreter is a special environment that you can access inside of the command line, which will allow you to basically test out different Python commands. So all you have to do is come over to the command line and you can just type in, in my case, Python 3. That's how it's stored on my computer. So I can just say Python 3, and this will open up this little Python interpreter. So in here, I could type in like Python commands. I could say like print hello, and you'll see down here, I can like test stuff out. So this is kind of like a sandbox environment where you can go in and test out like little Python lines of code or programs. Now, the interpreter isn't meant to be used as like an IDE or a text editor. This is just meant for like testing stuff. So you don't want to actually like write out full-on programs inside the interpreter, but it can be really useful if you're just trying to like try some different stuff out. So yeah, that's kind of like a basic overview of, a lot of the common things that you'll see in other programming languages in Python. So hopefully this kind of gives you an idea of how Python works. We talked about some of the best practices, and now you have an idea of what Python is, right? So it's kind of taken away a little bit of the mystery for you. Hey, thanks for watching. If you enjoyed the video, please leave a like and subscribe to Draft Academy to be the first to know when we release new content. Also, we're always looking to improve, so if you have any constructive criticism or questions or anything, leave a comment below. Finally, if you're enjoying Draft Academy and you want to help us grow, head over to draftacademy.com/contribute and invest in our future.